Introduction to Safety in Instrumentation and Control. Safety instrument system are control system that take the process to a safe state in terms of condition that may be hazardous or could eventually give rise to hazard if no action were taken. They perform safety instrumented function by acting to prevent the hazard or mitigating the consequences.
Hazardous area in instrumentation as per NES standard. Area where there is likelihood of presence of explosive gas air mixtures are referred to as zones. Zones are classified in the table below. The higher the number in a zonal classification, the smaller is the risk of an explosion. This is as per NES standard. Zone 0, an area in which an explosive gas air mixture is continually present or present for long periods. In Zone 1, an area in which gas air mixture is likely to occur in normal operation. In Zone 2, an area in which a gas air mixture is not likely to occur in normal operation, and if it occurs, it will exist only for a short time. And also, there are various zones such as Zone 20, Zone 21, and Zone 22.
Hello, let's see classification of material based on NES standard. Materials have been conveniently grouped into three basic classifications, that is metals, ceramic and polymers. This scheme is based on chemical makeup and atomic structure. Also there are some classification which based on the NES standard like composites, semiconductor, biomaterials, nano-engineered materials and
Explosion proof housing. The EX410 explosion proof housing is a fusion of aesthetic design and simplicity combined with a rugged, reliable operator interface for batching and monitoring processes and operation in hazardous area. From chemical filling into containers and IBCs to bulk loading of petroleum liquids in refineries and terminals. The EX410 is the perfect solution. As we can see in the diagram, it consists of simple 4 or 5 button operation with a large display area backed up by ingress protection to IP66. The EX410 cast aluminum housing is small enough to fit in the tightest of installations but allows operator easy to use access wearing gloved hands in all weather conditions. Features: cast aluminum housing, touch keys for added security, heavy duty Hall effect switches, protected IP66.
Encapsulation is a process by which one material or mixture of material is coated with another material. The material that is coated or interwrapped is most often a liquid but could be a solid particle or gas and is referred to by various names such as core material, payload, actives, fill or internal phase. The material that form the coating is referred to as the wall material, carrier, membrane, shell or coating. Encapsulation is used in a number of different industries with a wide variety of techniques or processes available. This overview will highlight techniques commonly used in a food industry.
Seals have a crucial impact on a system performance. Life and a reality of what is often considered a simple component can make all the difference to your products and operations. A seal can be a mechanical isolator between process and instrument, or it can be a part of a piping filled with a fluid. These protection methods are generally used with a pressure transmitter, DP transmitter, pressure gauge, and piping that connects this instrument to the process.
Immersion safety, a type of protection in which the electrical apparatus or parts of the electrical apparatus are immersed in the oil in such a way that an explosive atmosphere which may be above the oil or outside the enclosure cannot be ignited.
My topic is of purging system. So we'll see what is meant by a purge system. So as we all know, in a fire and explosion prevention engineering, purging refers to the introduction of an inert gases, purge gas into a closed system to prevent prevent the formation and ignitable atmosphere. Now we'll see what is the process of the purging. So basically, purging is the art of removing the contents of a pipe of container and replacing with all another gas or liquid. Purging is circular in pipeline, piping, welding, and industrial process. It removes the contaminants from the piping and vessels, which reduces the chances of corrosion.
Intrinsic safety is defined as it is a protection technique for safe operation of electrical equipment in hazardous areas by limiting the energy, electrical and thermal available for ignition in signal and control circuits that can operate with low currents and voltages. The intrinsic safety approaches simplifies circuits and reduces installation cost over the protection methods. Areas with dangerous concentration of flammable gases or dust are found in applications such as the petrochemical refineries and mines. As a discipline, it is an application of inherent safety in instrumentation. High power circuits such as electric motors or lighting cannot use intrinsic safety methods for protection.
Design for intrinsic safety. When installing electrical equipment in or near hazardous area locations, specific circuit design principles must be followed in order to prevent an explosion. Depending on the region of the world and the application requirements, different techniques or concepts are followed. In Europe, intrinsic safety is widely used. Circuit design in North America more commonly follows explosion-proof techniques. But that is changing as the benefits of intrinsic safety become more widely understood. Principle of intrinsic safety is typically accomplished using a protective circuit known as intrinsically safe barrier. In normal operation and in the event of a fault, the intrinsically safe barrier protects the field circuit by preventing excess energy from reaching the hazardous area. When considering the intrinsically safe circuit in a control system, there are three main components. First, the field device can be either a simple or non-simple device. Second, the field wiring, and third, the barrier. Intrinsic safety is based on the principle of preventing low voltage circuits from releasing energy to cause an explosion in hazardous areas, which is technically known as intrinsic safe barriers. The intrinsically safe barrier protects the field circuit in normal operation and in the event of a fault by preventing excess energy from reaching the dangerous area. We use the combination of a temperature transmitter and an intrinsically safe interface.
Isolation of equipment. The isolation is the process also known in the industry as lockout, tagout, and is used to isolate machinery equipments from its energy source. It is important to ensure the isolation of any unsafe machinery equipment from potentially uncontrolled energy source during repair and service.
Hello guys, my name is Virendra Das and I thank Kaya ma'am for giving this opportunity to present a video, and I also thank to my all group members for making this role play successful. Thank you for watching this video.